The topic of this video is finding the horizontal and oblique asymptotes of a rational function. Let's look at a problem. Find the horizontal and or oblique asymptotes, if any, q of x equals x cubed minus 27 divided by the trinomial x squared plus x minus 12. Okay, the first step in looking for horizontal or oblique asymptotes is to determine the degree of the numerator polynomial and the degree of the denominator polynomial. When written in polynomial form, which is a bunch of terms that are being added or subtracted, the degree is the highest exponent of x. So the numerator is degree 3 and the denominator is degree 2. Now compare the degrees of the numerator and denominator polynomials. We notice that our numerator denominator of 3 is greater than our denominator polynomial of 2. But by how much is it greater? Well, it's by 1 greater. This leads us to action C. If the degree of the numerator polynomial is 1 higher than the degree of the denominator polynomial, then use polynomial long division. If there is a remainder, then the quotient, discarding the remainder, is the oblique asymptote. A very important part of that particular sentence, or collection of sentences, is if there is a remainder, then the quotient is your oblique asymptote. Implied by this is if there is no remainder, then there is no oblique asymptote. So we need to do polynomial long division of this particular rational function. First, let's set up our polynomial long division problem. The numerator, x cubed minus 27, is going to go underneath our division bar. And because we are missing 2 terms, the x squared term and the x term, we have to place those in between the x cubed and the minus 27 with a coefficient of 0. Our denominator, x squared plus x minus 12, will go on the outside. To clear some space, I'll now move this over. Next, set up your columns. To the left of every add and subtract symbol in your numerator, put a vertical column, and then label your columns. So this is going to be the x cubed column, this is the x squared column, this is the x column, and this is the number column. Once you've done that, you're ready to begin the polynomial long division process. So take the first term of the lowest under and divide it by the first term of the denominator. We'll do this in our side workspace. So we have x cubed divided by x squared, which gives the result x. This is the first piece of our quotient. The quotient goes above the division bar in the appropriate column. Well, this is an x, so it goes in the x column. Next, take this newest part of your quotient and use it to multiply by your entire denominator. Distributing the x, we get x cubed plus x squared minus 12x. This result goes beneath the lowest under in the appropriate columns. The x cubed goes in the x cubed column, the plus x squared goes in the x squared column, and the minus 12x goes in the x column. Next, draw the line, change the sign, then combine. So, underline the terms that you just put in your long division problem and change the sign of each one. The positive x cubed becomes negative. The add x squared becomes subtract x squared. And the subtract 12x becomes add 12x. Now combine vertically. X cubed plus negative x cubed cancels to 0. 0x squared minus 1x squared makes minus 1x squared, or simply negative x squared. 0x plus 12x makes plus 12x. Now compare exponents. The highest exponent of x in the lowest under is 2. The highest exponent of x in the original denominator is 2. Is the lowest under 2 less than this 2? The answer is no, so we make another loop of polynomial long division. We take the first term of the lowest under and divide it by the first term of the denominator. So we have negative x squared divided by x squared, which gives the result negative 1. This is the second piece of the quotient. Therefore, it goes above the long division bar in the appropriate column. -1 is just a number, so it goes in the number column. Now use this most recent entry in your quotient to multiply by your entire denominator. Distributing the -1 gives us minus x squared minus x plus 12. All right, so now we're going to place this beneath our lowest under. So we have minus x squared minus x plus 12. Draw the line, change the sign, then combine. So this negative x squared becomes positive x squared, this subtract x becomes add x, and this plus 12 becomes minus 12. Now combine vertically. Negative x squared plus x squared makes 0. 12x plus x makes 13x. And this negative 27 minus 12 makes negative 39. All right, compare exponents. Biggest exponent here is 1, biggest exponent here is 2. Is 1 less than 2? Yes, so we stop. So this is our remainder. This is our quotient. And with these two things, we can now address the question that we are being asked, which is to find the horizontal or the oblique asymptote. Let's reread action C. If the degree of the numerator polynomial is 1 higher than the degree of the denominator polynomial, then use polynomial long division. Done. If there is a remainder, then the quotient, discarding the remainder, is the oblique asymptote. So, did we have a remainder? Yes. Therefore, we will have an oblique asymptote, and its equation is y equals this quotient, x minus 1. So, the answer to this question is there is an oblique asymptote, and its equation is y equals x minus 1.